My research is primarily involved with finding planets around other stars in our galaxy, and the big questions that we're trying to answer are things like how many planets there are around different stars in our galaxy, whether all stars have planets or not many do, the type of planets, whether they're small planets like Mercury or Earth, or whether they're large planets like Jupiter, Uranus, Neptune, and where those planets are found in relation to their parent stars, whether they're very close in, like Mercury. In fact, many of the planets that we've found have been very close in, even closer to their stars than the orbit of Mercury. But then we're also interested in how many planets are out in their more distant regions of solar systems, out near where we would find Neptune or Jupiter in our solar system. The method I use is called microlensing. The way that works is that we observe millions of stars that are located near the centre of our galaxy, and occasionally there will be a star that's sort of about halfway between us and those stars that will pass in front of one of those stars. And when that happens, that foreground star that we call the lens can actually bend the light of the background star and focus it towards us and make it look brighter than what it would if there was no lens star there. And that's a transitory phenomenon. It lasts about anything from a few days to a few hundred days. But it's a very rare phenomenon. In fact, only about 1 in every million stars is that happening to at any one time. So you might ask, how does that relate to planets? Well, in fact, what we're able to do if we monitor and analyse those signals very closely, we can sometimes detect the presence of planets around the star that's the lens star. We have 3 new identical telescopes that are located in Chile, Australia and South Africa. And the reason for having 3 is that we can observe our regions that we're interested in the centre of the galaxy 24 hours a day, weather permitting. So when the sun rises and it's daytime in Chile, it's nighttime in South Africa. These telescopes are quite wide field. They don't zoom in very closely, and we have very large cameras that go on those telescopes. We have 300 megapixel cameras. They're about some of the largest ones in use in astronomy. And with a single exposure, which takes about 2 minutes to acquire, we can detect several tens of millions of stars in a single shot. The project is primarily run by or funded by the South Korean government, Korean Astronomical and Space Science Institute. They built the telescopes and funded the building of the cameras, and they acquire much of the data, but there's a few others of us around the world who work with them as part of the project. Technically, the thing we're trying to measure, we call it the planetary mass function, and that is how many planets are there per star as a function of the mass of the planets and their location, their distance from their parent stars. The type of contribution we can make is primarily we're attacking the end of that function, which is the distant end. It's not planets that are located really close to their stars, it's ones that are located further from their stars. We're about the only technique that can measure these low mass, can find planets like Earth that are located at Earth-like distances from their stars or further out.